we saw that direct proofs are just a sequence of implications that started the hypothesis and reached the conclusion. Proof by contrapositive is essentially a direct proof, except it with a twist at the start. So recall that a statement P implies Q has the contrapositive, not Q implies not P. So the hypothesis and conclusion are flipped, and then they are negated. And we saw that these two are logically equivalent. So proving P implies Q is the same as proving not Q implies not P. And so proof by contrapositive starts with the negation of the conclusion, and through a sequence of logical direct implications, you reach the hypothesis, the negation of the hypothesis. And typically, we use proof by contrapositive when it is the case that the negation of the conclusion is easier to describe than the hypothesis. It's an example. So we saw earlier on the proof that sum of two rational numbers is rational. Let me twist it slightly. So I want to prove that if sum of two real numbers is irrational, then at least one of the two numbers is irrational. Okay, so here my assumption is that sum of two real numbers is irrational, and my conclusion is that at least one of the two is irrational. Now, let's start with scratch work. Suppose I try to give a direct proof of this. Then my assumption would be that x and y are real numbers and x plus y is irrational. And my conclusion needs to be that either x or y or both, here or is used in the mathematical sense, irrational. Now the problem is that we don't have a good description of what an irrational number is. We know what a rational number is. It's a ratio of two integers. But what is an irrational number? It's something that is not rational. I don't know how to simplify anything in here. I'm just stuck at this point. So now I'll try the negation of the conclusion as my hypothesis. So negation of or becomes and. So I'll get x and y. So this is now attempt 2. So that's gone. The above one, I'll just literally scratch it. And let's start over again. This is very common that some proof doesn't work and then you start over again. That's just life. So x or y irrational, so negation is x and y irrational. This looks promising. I know how to describe this very precisely. And the negation of x plus y irrational is x plus y irrational. This is great. This is a problem that we have already done. Start the proof directly. I don't need any more scratch work because I know how to solve this problem. I've reduced the problem to a problem that I know how to solve. We will prove contrapositive instead. Negate the conclusion if both real numbers x and y are rational. Then their sum is also rational. Okay, and this is exactly this thing I did in the previous video. So I won't do this completely. I'll just leave it at that x is equal to p over q s, where p, q, r, s are integers and q not equal to 0 and s not equal to 0. And so on. Literally just copy paste the previous proof here. typically what happens is proving the contrapositive is just as hard as giving a direct proof. So we don't always try to switch to the contrapositive, but sometimes it does happen that the negation of the conclusion is easier than the hypothesis, and then you just do it by contrapositive.